if you're graphing y is equal to x versus y is equal to negative x, if it's a linear function, that means your line is passing quadrant 3, right? Because this is quadrant 1, 2, 3, 4, versus something like y is equal to negative x, which is quadrant 2 and quadrant 4. Does that make sense? So the negative leading coefficient or the positive leading coefficient would determine whether your function is passing quadrant 1 and 3, if it's let's say y is equal to x, versus quadrant 2 and 4 when it's a negative leading coefficient. Same thing really applies for example, y is equal to x cubed, right? Which is what we know is an odd function, right? So we have something like this. So we know that it's quadrant 3 and quadrant 1 when it's positive, and if it's negative x cubed, we know that this is quadrant 2 and quadrant 4. And guess what? It's similar to y is equal to x squared, right? So let's just scroll down just to see and compare them. So y is equal to x squared. This is going to be on quadrant 2 and quadrant 1, right? And if you have y is equal to negative x squared, you're going to have that on quadrant 3 and quadrant 4. Does that make sense? So it matters where you're going to graph that. Okay, so I can erase this now. So that's for the sign of the leading coefficient. So let's move on to multiplicity versus degree. So you've probably heard what multiplicity is, and also zeros, right? Zeros and multiplicity are related to one another. So for example, you're looking at x, right? So first of all, you have x minus 3, and you have x plus 4, right? So your zeros are going to be 0, right? Because x is a 0. And you have positive 3 and negative 4. So maybe we can just group this based on the smallest versus the largest. So we have negative 4 to begin with because it's x plus 4 is equal to 0. Therefore, you're going to get negative 4, right? And then you have 0, comma 3, right? 0 for your x minus 3 is equal to 3, right? So in that case, you're going to see that the multiplicity of x plus 4 is going to be 1, right? So what is multiplicity? So multiplicity is when you're looking at different terms, and then you call this sort of like an exponent. So if you look at x plus 4, your exponent right here is actually 1, right? So the multiplicity of negative 4 is actually 1. Multiplicity of x minus 3 is also 1, right? So let me erase this so you can see everything. So this is 1, right? This is multiplicity of 1, and this is also multiplicity of 1 because all of your exponents are actually 1. Does that make sense? Okay, so multiplicity is 1, 1, and 1, right? However, if you're looking at the degree of your function, that means the degree is your summation of all your multiplicities, right? It's going to be 3, right? Because 1 plus 1 plus 1 is 3, right? So the degree of your function is 3. Okay, so why does the degree matter? Well, the degree matters because at least you know which quadrant it passes through, right? Because if you're thinking about an odd function versus an even function, right? This is what I tell my students to really remember during the test. So if you're looking at, let's say, a negative leading coefficient, if it's an even function, so say for example, you have negative x squared, right? You would have to, so this is the one that we talked about earlier, you would have to look at quadrant 3 and quadrant 4, right? So you know where your function is going to start and where it's going to finish. So it's going to start at quadrant 3 and then you're going to finish at quadrant 4. So that's the position of where you're going to draw. However, if you're looking at y is equal to negative x cubed, you know that it's not at quadrant 3 and quadrant 4 because it's actually at quadrant 2 and quadrant 4. Does that make sense? So when you draw this graph, you know that if it's degree 3, therefore it's an odd function, right? And if it's an odd function, you're supposed to expect that this is what the quadrants, or this is how your graph is sort of going to look like. So these are what you call like templates that I like to tell my students to remember during the test. So you have an idea of where you're going to start drawing the graph, because otherwise it's just going to be overwhelming. Okay, so now that we have that, we're going to have a number line, and then you're going to graph all of your, sorry, not graph all of your zeros, but plot them, right? So this is -4, 0, and 3. Okay, so we know that this is all of your zeros, and then first of all, because it's a negative leading coefficient, it's an odd function, you're supposed to start